In this video, you're going to learn how to graph Limaçons, and we're going to go through the 4 different types. We're going to go through 4 examples showing you the different types, and then I'm going to give you 4 examples that you can practice on your own, and I'll kind of mix them up, and you can figure out what type it is and how to sketch it, and then we'll go through it together so you can kind of check your work and get some practice. So let's dive in. So when you think of a Limaçon, Limaçon is the French word for snail. So you'll notice that when you graph these, it looks kind of like the shape of a snail. And here you can kind of think of this as kind of like the shell, and this is maybe like the head of the snail. It's kind of like turned sideways here in this particular example. But when you're dealing with a Limaçon, you'll notice that the equation is in this form, like r equals a plus or minus b cosine theta, or r equals a plus or minus b sine theta, where a and b are just like numbers. And these are like 2 terms separated by plus or minus. And so that's how you can kind of tell that you're dealing with a Limaçon. Now, how do you know whether it's going to be one that has an inner loop, like this one here, or a cardioid, kind of like a heart shape, or dimpled, where it's just kind of like just a little bit kind of curved in there, or convex? What you want to do is you want to take the ratio of a divided by b. So if a divided by b is less than 1, then you're going to have this inner loop here. If it's equal to 1, a over b, then it forms like a cardioid or a heart shape. If a over b is in between 1 and 2, we say it's dimpled, so just kind of a little bit kind of pressed in there. And if a divided by b is greater than or equal to 2, it's convex. Now convex, it's almost kind of like it's just flattened on one side. Remember from geometry, convex is if you put 2 points inside of the figure and you connect them, that line segment will be entirely inside of the figure. So convex as opposed to concave, where it's like caved in. So let's dive into the 4 examples. The first one we want to look at is r equals 1 plus 2 cosine theta. So you can see here a is 1 and b is 2. So if we take our ratio of a divided by b, that's 1 over 2, which you can see is less than 1. So that means we're going to have an inner loop. So we can use this as a guide. Now the other thing that's interesting here is that when you see that it's in terms of just cosines, this polar equation, we're going to know that it's going to be a reflection over what's called the polar axis, or like this x-axis here, this horizontal axis. So we can reflect it over that line to get the other half of the graph. Sometimes you can use that as a guide to help you. Now, one way to approach these graphs, I like this method, is to graph it in the Cartesian plane, kind of like an XY plane, almost as if you're trying to graph y equals 1 plus 2 cosine x. Here's your x-axis, here's your y-axis. Well, we know that the 1 shifts the graph up 1. Okay, so this is kind of like our new midline. And we know what the cosine graph looks like. It has an amplitude of 2. So what this is going to look like, it's going to start up here at the maximum. At pi over 2, it's going to go down to the midline. At pi, it's going to go 2 below that midline. At 3 pi over 2, we're going to be back at the midline. And then at 2 pi, we're back at the maximum here. So this is going to be like a sketch of our equation in the Cartesian form, but we're going to use it to help graph our polar graph over here. So instead of this being like our x-axis, this is like our angle theta. Instead of this of like our y-axis, this is like our r value, or like our radius, okay? And so now what we're going to do is we're going to go ahead and transfer over here. So we can see that when you're at 0 radians, that's going to be right here, the r value, or the distance from the pole, is going to be 3. So I'm going to go out 1, 2, 3, and there's going to be a point right here. Now, as I make my way to pi over 2, that's like rotating 90 degrees counterclockwise, you can see I'm coming down to 1. Okay, so that means this point's going to be right here at 1. And now as I make my way down to pi here, so I'm rotating 180 degrees, you can see I'm here at -1. Okay, and so -1, what happens when you go like this to 180, you're going to go through the pole to the other side when it's a negative r value. So you're rotating like this, you're going through that pole like so, and then continuing back on, as we make our way to 3 pi over 2, which is 270 degrees, we're going to be at 1, okay, which is going to be right here. And then at 2 pi, where we make one full revolution, we're back to 3. Now, we know that this has an inner loop, okay, like so. But what we might want to do is we might want to find out where are these zeros here, meaning where is it crossing the x-axis? Well, we can set this equation equal to 0 and solve. So let's say 0 equals 1 plus 2 cosine theta. Let's subtract 1 and divide by 2. So negative 1/2 equals cosine theta. And we ask ourselves, knowing what we know about the unit circle, where does cosine equal negative 1/2? Well, that's going to be at a 2 pi over 3 and 4 pi over 3, right? So 2 pi over 3, that's going to be somewhere along this line right here. 4 pi over 3 is going to be somewhere along this line right here. So what that's telling us is as we're rotating, so you notice from 0 to pi over 2, that r value is getting smaller and smaller. So what this is doing is it's like pulling it in, almost like a magnet, or it's like you're reeling it in, right? It's getting, the r value, this distance from the pole to here is getting smaller, 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 okay, like this. And then at 2 pi over 3, that's this angle right here, it's going right to 0, right? That's where it's crossing the x-axis here. And then what happens is now, see, when we're below the x-axis, that r value is negative, which means that instead of going outward, we're actually going through the pole to the other side. So it's going like this, okay? And now what's happening is you can then reflect that over that polar axis, that x-axis, and so that your graph's going to look something like that. So there you can see there's an inner loop like that. Now, just so that you know, this could be where the inner loop is like on the other side, where you could basically have this kind of like reflected. So it could be more like this. That's one option. Or it could look like this. Okay. Or it could look like this. Oh, I kind of did the same one. So it could be, so basically you could flip this. You could have it like where this inner loop is up here and it's been reflected. So those are all the different types of the ones that have an inner loop, whether it's a reflection over the polar axis or the line theta equals pi over 2, this like y-axis here. Let's take a look at the next type. Okay, for example number 2 now, we've got r equals 3 minus 3 sine theta. Again, this is a Limaçon, because you can see we have this a minus b sine theta. It looks something like this form right here. But what we want to do to help us is to figure out what type of Limaçon is it. So let's look at the ratio of a divided by b. So in this case, a divided by b, that's 3 over 3, which is equal to 1, which tells us that it's a cardioid. And cardioid, you think of like cardiac, like heart, right? So it's heart-shaped. So what we're going to do now is we're going to graph this in the Cartesian plane, this like xy plane, and then we're going to use that to transfer it over to our polar graph. So we're going to use this to kind of help us. I like this method. I think you'll like it too as you get used to it. The key though is really knowing how to graph your sine and cosine graphs. Now we know that the 3 shifts the graph up 3 units. So we can think of this kind of like a new x-axis or a new midline. And then we're going to graph negative 3 sine theta. Okay, so it's like we're graphing y equals negative 3 sine of x from here. So the sine graph, we know, looks something like this, but the negative is going to reflect it. So we're going to start right here at the midline, then we're going to go down 3, okay, to the minimum, back to the midline at pi, then to the maximum, which is up here at 6, at 3 pi over 2, and then back to the midline at 2 pi. Okay, so now let's go ahead and sketch that. So our graph looks something like this. Of course, it repeats, right? But what we're going to do is we're going to use this as a guide. So we're going to say that when our angle is 0, so that's right here, okay, along the positive x-axis, we're going to be at an r value of 3. So we're out 1, 2, 3 right here. Okay, now as we make our way to pi over 2, you can see the r value is getting smaller, smaller, smaller until it goes to 0. So what that means is as I rotate towards 90 degrees, pi over 2, the r value is getting smaller. It's basically like you're reeling it in, okay, like with a fishing rod or a magnet. It's pulling it in towards the pole or the origin. You can think of that like that's 0, r is 0. And then now, as we make our way to pi, Okay, so 180 degrees, so 90, 180 is over here. The R value is getting larger and larger. So it's going back out to an R value of 3. So 1, 2, 3 would be right here. So it's kind of going out like that. Now, one thing that you'll notice is that, see how this is in terms of sine? That tells us it's going to be a reflection over the line theta equals pi over 2, or you can think of this kind of like our y-axis, right? So it's a reflection. Okay, now as we go from pi to 3 pi over 2, the R value continues to get larger and larger, so we're getting further and further away from the pole. So I'm rotating from 180 to 270. I'm going out to an R value of 6, which is right here. So again, kind of making its way further and further out. And then as I go from 3 pi over 2 to 2 pi, okay, 3 pi over 2 to 2 pi, the R value starts to get smaller. It approaches an R value of 3, which is right here. And so you can see there's that, I'll try to darken it a little bit here for us. There's that reflection over the line theta equals pi over 2. And you can see that heart shape. Now you might be saying, Mario, that's not how my teacher showed me. My teacher showed me you make a table, theta and R, and you start putting in values. Like you could put in 0 and then pi over 6 and pi over 4 and pi over 3 and pi over 2. And you can go all the way around the circle if you want. And that's a good technique. Of course, what about pi over 12 or pi over 18? There's a lot of points, and to get a perfect sketch, you're probably going to have to use like a graphing calculator or a computer. But what this is hitting on, it's hitting on some of the key points. You can see the maximum, the minimum, right, or the 0 where it's going back to the pole, and it's seen in a nice visual way this way. So I like this technique. I also like knowing kind of the ratios of A over B, so I know going into it what type of shape I should expect. And you can use the symmetry like we talked about here if it's in terms of sines or cosines. So let's look at the third type. Okay, let's look at the third type now. So the third type, we've got R equals 3 minus 2 cosine theta. Again, notice the two terms separated by plus or minus. We know we're dealing with a Limaçon. We want to figure out what type of Limaçon by taking the ratio of A divided by B. So here you can see A divided by B equals 3 over 2, okay, which is 1.5, and 1.5 is in between 1 and 2. This is going to be a dimpled Limaçon. So it just has a little indentation there. And when we graph this, we're going to think about graphing the graph y equals negative 2 cosine theta plus 3. All I did is move the 3 over here, plus 3. So the plus 3 shifts the graph up 3. We can think of that as our new x-axis or our new midline. And I should have meant this an x, like this is like an xy Cartesian graph. And then this is a cosine graph with an amplitude of 2, but it's been reflected. So we know the cosine graph normally looks like this. Now it's going to be reflected, so it's going to look like that. So what we're going to do is we're going to start at 2 below the midline, then we're going to go to the midline, 2 above the midline, back to the midline, and 2 below. So basically there's our reflected cosine graph, and we're going to use that to transfer it over to our polar graph, thinking of this as our angle theta and our R value instead of the y-axis. Okay, so let's see, starting at 0 radians or 0 degrees right here, we're at an R value of 1. So that means we're going to be out from the pole 1 unit right here. Okay, then as we move towards pi over 2, that's 90 degrees like that, you can see the R value is getting larger, larger, larger until it gets to 3. So that means that we're spiraling out to 1, 2, 3 right here. So this is kind of going out like this. Okay, notice how that distance is getting further, further, like that as the angle rotates. Okay, then we get to pi, we reach a maximum here of 5. So pi we know is 90, 180 over here, and we're at 1, 2, 3, 4, 5 out from the pole. Okay, so it's again still spiraling out like that. And now we know that this is in terms of cosines, which tells us that it's a reflection over this horizontal axis. It's called technically the polar axis, or you can kind of think of it as the x-axis. You could reflect all these points, or we can continue on here with this graph going to 3 pi over 2, which is 270. We're going to be at an R value of 3, so that's going to be, let's see, 1, 2, 3 right here. You can see it's a reflection of that point. And then when we get to 2 pi, which is back to 0 there, we're at an r value of 1, which is right here. So basically, I'm just going to try to reflect this over. Something like that. So let me see if I can darken it a little bit for us so we can see it a little bit better. But notice it's kind of like a cardioid. It's kind of like almost like a heart shape, but not as extreme. Just a little pushed in there, just a little dimpled right there. So we call that a dimpled Limaçon. And again, reflected over the polar axis because it's in terms of cosines. And you got it. So let's look at the fourth type. Number 4, we've got r equals 6 plus 2 sine theta. So let's start by figuring out what type of Limaçon it is by taking the ratio of a divided by b. So in this case, a divided by b, that's 6 divided by 2, which is 3. And you can see that that's greater than or equal to 2, which means that this is going to be a convex Limaçon. So what we can do is we can think about graphing the equation y equals 6 plus 2 sine x, and then use that to graph our polar graph. So I know that the 6 is shifting this midline up 6. 1, 2, 3, 4, 5, 6. So everything gets shifted up 6. That's kind of like our new x-axis. I'm graphing sine graph with an amplitude of 2. So it's going to go up 2, back to the midline, down 2, back to the midline. Okay, so that means this is going to be, this is 6, this is 8, and this is 4. So that gives us our basic points here. And now when we graph it, so when you're at 0, which is right here, we're at an r value of 6. So that's going to be right here. And then as we make our way to pi over 2, rotating 90 degrees like that, we go out to a maximum of 8. So that's going to be right here, 8. So it's going kind of out like that. Okay, and then at pi 180, we're back to 6, so that's going to be right here. Okay, roughly like that. And then at 3 pi over 2, we're at 4. 1, 2, 3, 4, right about here. And then at 2 pi, we're back to 6. So I'll try to darken this a little bit here for you, but what you can notice is that, see how this is kind of like flattened, I guess? It's not like a perfect circle. It's almost kind of like, it's kind of just like a little bit, flattened. It's not dimpled. It's not like a cardioid. Of course, obviously there's not an inner loop. It's just kind of, a little bit flattened, and that's what's called a convex Limaçon. So now what we're going to do, and I encourage you to do this, is I'm going to mix these up, okay, so they're not going to be in the same order. See if you can recognize what form it's in, and see if you can get a good sketch of it, and we're going to go through them together so you can kind of check your work. So let's do that next. Okay, see if you can pause the video and do number 5. We've got r equals 2 minus 2 cosine theta. What type of Limaçon is it, and what does the graph look like? See if you can do it. Now, if it was me, I'm going to follow the same process I've been following. I'm going to first look at the ratio of a divided by b. So 2 divided by 2 is equal to 1, which tells us that it's a cardioid, okay, like a heart shape. And I know that since this is in terms of cosines, this is going to be a reflection over the x-axis, or what we call the polar axis. So those are clues. And then I can take it one step further and think about, what does the graph of y equals 2 minus 2 cosine x look like? Let me use that to help me graph my polar graph. The 2 we know shifts everything up 2. This is a cosine graph that's been reflected in an amplitude of 2. So cosine would start, normally starts at the maximum. Now it's going to start here at the minimum. Midline, maximum, back to the midline, and back to the minimum. So the graph would look something like that, roughly. Okay, so now at 0 radians, we're at an r value of 0. That means we're right at the pole. So these are referred to as the zeros, okay, or where it comes back to the pole. Now, as we go to pi over 2, which is like 90 degrees, the r value is getting larger and larger. It's going out to an r value of 2. So that's going to be right here. So what's happening is it's spiraling out. See how the distance from the pole is getting longer, longer, longer. So it's making its way. As you're turning, it's getting further away. Now, as we go to pi, Again, the R value is continuing to increase until it gets to a maximum of 4. So as I rotate from 90 to 180, it's getting further and further until it gets to this R value, or this distance from the pole, of 4. So kind of going like that. And now if we wanted to stop there, we could just reflect it over the polar axis to get the rest of the graph. But let's just continue on here. So from pi to 3 pi over 2, that's from 180 to 270, we're going back to an R value of 2. So it's kind of like you're reeling it back in, right? So it's going back to 2. It's getting closer. So it's turning and it's being pulled back. You know, it's like two forces. You got this turning force and then you got this pulling back to the pole or the origin force. And then as we go from 270 to 360 or 3 pi over 2 to 2 pi, we go to 0. So basically it's turning, but it's also getting pulled into the pole. So let me darken that a little bit so you can see it a little bit clearer on the video here. It's a cardioid shape, that heart shape, and that's the graph. So cardioid, right? Okay, let's go ahead and do the next example. See if you can do number 6 now. R equals 4 minus cosine theta. So go ahead and pause the video. It's good to practice even if you make mistakes. You'll learn from those mistakes. Remember, math is not a spectator sport. We want to get in the game, right? Okay, so how do we graph this? Well, first thing I like to do is figure out what type of Limaçon are we dealing with. And I have to take the ratio of A divided by B. Now, there's not a B here, which means it's understood to be a 1. So A over B is going to equal 4 over 1, which is 4. That's greater than or equal to 2. That tells us that it's a convex Limaçon. Taking it one step further, it's like in terms of cosines, which means it's a reflection over this x-axis or this polar axis. And taking it one step beyond that, let's go and graph it in the Cartesian plane, the xy plane, by graphing y equals 4 minus 1 cosine x. The 4 we know shifts it up 4. So there's like our midline, or like our new x-axis. It's a cosine graph that's been reflected. Okay, so that means it's going to start here at the minimum, midline, maximum, midline, minimum. Okay, so it's basically going in between 3 and 5. 3 is the minimum, 5 is the maximum. And so let's go ahead and graph this. So starting off at 0, that's right here, we're going to be at an R value of 3. So out from the pole, 1, 2, 3, right there. And then now you can see as we go to 90 degrees, or pi over 2, the R value is getting longer or larger or further from the pole out to 4. So that means we're going to be right here. Okay, so this is kind of like spiraling out like that. And then at pi, which is 180, it's going to go out even further to an R value of 5. So it's going to go like this. And then at 3 pi over 2, we're back to 4. And then at 2 pi, we're back to 3. So I'll kind of try to darken it a little bit, but you can see it's almost like a circle, but not quite. I mean, it's kind of a little bit, kind of a little bit flattened on one side, a convex Limaçon. Let's take a look at the next example. See if you can do number 7. We've got R equals 1 minus 3 sine theta. So pause the video, see if you can do that one and get a good sketch of the graph. Now, as you know, the way I like to do it is to analyze the A over B, which in this case, A over B is 1/3, which 1/3 is less than 1, which tells us that we have an inner loop. These, I think, are kind of like the scariest ones, okay, because what happens is you get a negative R value, and it's like, what do we do? But I'm going to show you how to do this if you haven't done it already. So the first thing we want to do is we want to now realize that this is a sine in terms of sine, which means it's going to be a reflection over the y-axis, or this theta equals pi over 2 line. We can also graph it in the Cartesian plane by looking at the equation y equals 1 minus 3 sine x. The 1 we know shifts the graph up 1, so this is kind of like our new midline. It's a sine graph that's been reflected with an amplitude of 3. So sine starts at the midline, goes down to the minimum here at -2, back to the midline, back to the maximum, which is going to be at 4, and then back to the midline. So our graph should look something like this, roughly. Okay, so now let's go to our polar graph. So we say at 0 radians, or 0 degrees, we are at an R value of 1. So we're going to start right here, 1 unit out from the pole. Now, this is interesting. See how it crosses the x-axis here? That's where our R value is 0. So that's like our, what we call our 0, or it goes back to the pole. Now you can see that this is, you know, it's just a little bit more than 0. So it doesn't take much, like it's just a little bit of a rotation, okay? And you're pulling it back right to the pole. Okay, see that? Now, as we make our way out to pi over 2, okay, which is 90 degrees, this goes out to an R value of -2. Now, normally, we'd be at +2 up here, but when it's a negative, we have to go through the pole to the other side over here. So what's happening is we're going to end up right here. As we're rotating, this R value goes negative on us like that. Okay, so instead of going out this way, I go through the pole the other side. Okay, that's part of the inner loop. Then as we make our way towards pi, okay, so we're rotating our angle towards 180 degrees, we're still at a negative R value, which means that if I'm over here, I'm on the other side, I go through the pole to the other side. But we also know that this is in terms of sines, which means it's a reflection over this line, theta equals pi over 2. So I pretty much know that this graph, if I just reflect it, this graph's going to look something like this, right? And continuing on like that. So basically I can see at pi, now the R value, see it's above the x-axis, the R value is positive. I'm at a +1. So when I'm at 180 or pi, I'm 1 out from the pole in the same direction. When it's a negative R value, you have to go the opposite direction through the pole to the opposite side. Now from pi to 3 pi over 2, so from 180 to 270, now we're going out to an R value of 4. Okay, so that's going to be, let's see, 1, 2, 3, 4 right here. And I'm turning, and I'm also going further away from the pole. So I'm spiraling out. Maybe I should have made it a little bit more like that. And then I could reflect it over and get the rest of it, or if I just continue on here from 4 to 1 as I go from 270 to 360 or 3 pi over 2, the R value gets pulled back to 1 like that. See here, R is 1. So you can, let me darken it a little bit for us here. So basically we have this Limaçon, this snail. It's almost like an upside down snail, right? Here's the head of the snail. Here's like kind of the shell. And kind of looking at you towards the camera. So this is a Limaçon with an inner loop. So let's do the last example now. Okay, see if you can do this last example, number 8. R equals 4 plus 3 sine theta. And you can pause the video and then, you know, I'll go over it with you in a minute. But I want to mention something before we finish this video that I think you're going to be interested in, and that's that you can join the channel now as a channel member. And if you join at that additional videos level, you can have access to over 120 now additional videos. And some of the videos that in particular I think could be interested in are my pre-calculus midterm and my pre-calculus final exam reviews. So if you're getting ready for some finals and some midterms, check those out. Those can be of a great help to you, as well as some of the other videos that are on there. You can check it out. And so go ahead and do this last problem. The first thing I would do is I would look at the ratio of A divided by B. So A divided by B, in this case, is 4/3. And 4/3 is 1 1/3. That's in between 1 and 2. So that tells us we're going to have a dimpled Limaçon. And I know that this is in terms of sines, which tells us it's going to be a reflection over this line theta equals pi over 2, or like the y-axis. But let's see if we can graph it in the Cartesian plane by thinking of this as y equals 4 plus 3 sine x. So the 4 shifts it up 4. That's kind of like our new x-axis or our new midline. It's a sine graph with an amplitude of 3. So that's going to go up to the maximum here at 7, back to the midline at 4, down to the minimum, which is 3 below the midline at 1, back to the midline at 4. So that gives us our basic sine graph there. And transferring it now over to our polar graph, we're going to say at 0, we have an R value of 4. So at 0, we're out from the pole 1, 2, 3, 4, right there. And as we go out to 90 or pi over 2, we're going to be at an R value of 7. Okay, so that's going to put us right here. So spiraling out like that, roughly. And then to pi, we're back to 4. So 1, 2, 3, 4. I should have rounded this out a little bit better. And then at 3 pi over 2, we're to 1. So when we rotate to 270, we're going to be at an R value of 1. kind of like that roughly. And then from 3 pi over 2 to 2 pi, we're back to an r value of 4. Of course, we know it's a reflection over the y-axis or the line theta equals pi over 2. And I'll just try to darken this a little bit here for us. You can see there's that dimple, okay, kind of like a dimple on somebody's face, you know, just a little indentation, little dimple. And that's our dimpled Limaçon. So great job if you're able to follow this video. I'll put a link to a video I think you'll find interesting right there. Go ahead and follow me to that video. We'll get some more practice, and I'll see you in my other videos. I'll talk to you soon.